matching and allocation problem. So here we're trying to determine whether we can match, for example, in this one here, a teacher with instruments. And considering we only have 4 teachers and 5 instruments, then this is unable to be done because we've got too many instruments. But what this thing is called that we've just drawn up is a bipartite graph, and it should always be directed. Every bipartite graph should be directed. Then we've got this complete weighted bipartite graph, which means, as you can see, that employee number 1 can go to machine 1, 2, 3, 4, same with employee number 2, 3, and 4. This is what we call a completed bipartite graph. We need to make an allocation to fit. So what that means is we're trying to either get an allocation where one person goes to a particular machine, for this case, or above a teacher goes to a particular instrument if they were the same amount, where it will give us the minimum time or the minimum cost to do this. So one person has to go the other. Now, and then we can draw up this bipartite graph and we can work out our cost matrix. So we do that using this thing called a Hungarian algorithm. Now the steps are written below. So this is the original table, and this is where we get our original data from when we're working out our cost. Now the first step is to subtract the lowest value in each row from every value in that row. So if I look in this row over here, Wendy's row, the lowest value is 30. So I'm going to subtract 30 from all those numbers. So I get the 0, the 10, the 20, and the 30. For Xenophon, the lowest value is 30. So I subtract 30 from all those, and I get 40, 0, 10, 40. For Yolanda, the lowest value is 30. Subtract 30 from all the numbers, I get that. And Zelda's lowest value is 20. Subtract 20, I get that. The next step is to try and draw a line through as many zeros as possible, the smallest number of lines. So here I can draw a line straight down, where I have here, here, and here, and I get 3 lines. If I had got 4 lines, now remember I'm trying to do it in the minimum number of lines. If I had 4 lines, then that would be great. I can do my allocation. So if the minimum number of lines required to cover all the zeros in the table is equal to the number of allocations to be made, in this case 4, we jump to step 6. Otherwise, we continue. Now in this case, there's not. There's only 3 lines that we can cover the zeros with. So what I do now is in every column that does not have a 0, we subtract the lowest value in that column from all the other values. So if we look at column A, that's got a 0, so I'll just keep those numbers. There they are there. Column B has a 0, so I'll keep those numbers. Column D has a 0, so I'll keep those. Column C doesn't have a 0, so the lowest number is 10, so I subtract 10 from all the numbers. So I get 10, 0, 20, 20. Now I try and cover my zeros up again with the smallest amount of lines. And yes, I could go straight down A, B, C, D and get 4 lines. That's not a problem. But I can cover them this way and only have 3 lines. Again, the minimum number of lines does not equal the number of allocations. So now we've done the row, we've done the column. This is important now. After we've done the row and the column, what we have to do, the one that is uncovered, we find the smallest value and we add it to any value that is covered by 2 lines. And then there's a second step. The second step says we must subtract the smallest uncovered value from all the covered lines. So in other words, this is what we have to do. Smallest number, uncovered, number 10. We subtract it from all the ones that have a line, we add it to all the ones that have a line in. So this 0 would get a 10. This 40 gets a line this way, that's 10, and a line this way, that's 10, so it goes to 60. This 30 gets a 10, and this 0 gets a 10. This 30 here gets a 10. This 0 gets a 10, this 0 gets a 10. This 40 got two lines, one this way and one this way, so it gets a 10 twice. This 0 gets a 10, and this 50 gets a 10. Okay, so that's what you should be doing. Then you need to take, that's the first step. The second step is to subtract it from all of them, from every single one of them. So when I subtract 10 again from every number, okay, I would be getting 0. This becomes 50. I'll change my colour. So this is a 0, which is what I've got. This becomes a 50. This becomes a 30, and this becomes a 0 again. This becomes a 0, 0. This goes back to 0, 0, 10, 50, 10, 10. This one, 40, goes back to 30. This 60 becomes a 50. Take away 10. You only take it away once. 50 and, well, that was a 10, sorry. That's a 10 there, so back to 0. So really, we can do both steps there. Or if we're smart, we can just add 10 to the one that's got two lines, and all the other covered ones we leave, and then all the uncovered ones we just take away. But it's up to you. So I end up getting this. Now we do our lines again. How many ways can I cover the 0? Smallest number of lines. And this time I get 4 lines. 1, 2, 3, 4. Because I've got 4 lines, and that equals 4 allocations because I've got 4 people, then I can do my bipartite graph, and it should be directed. So where the zeros are is where the person's going to go. So there's Wendy, Exafine, Yolanda, Zelda. There we go, all written. A, B, C, D, there you go. Now Wendy should go A, B, or C because that's where the zeros are. So A, B, C, directed. It's got an arrow on it. Xenophon has a 0 at B and C, so that person's only going to go to B and C. Yolanda can go to D only, and Zelda can only go to A. And it's all directed. Now this is easier to do. Now we're going to do our cost matrix. So instead of writing like that, we're going to go W, X, Y, and Z to... Now Zelda can only go to A. Yolanda can only go to D. That leaves, we'll do Xenophon first, can go to B or C, and Wendy can go to B or C. So it doesn't matter. I'm going to put Wendy B and this one C, work out this cost, but my other one here, W can go to C, X can go to B, and the other two still stay the same, and Zelda to A. So now we're going to get, you'll find it's exactly the same. To do this, we have to go back up to the start. So back up to this one here. Okay, we must do it from there. We can't do it any other way. So I've got it written down, so I'm just going to come back here. So W to B is 40. X to C is 40. Y to D is 30. And Z to A is 20. And if I add all that up, I get 130. That's what we've got there, 130 minutes. If I went W to C, I'm still going to, and I'll do this one, I'm still going to get 130. It's all minutes, right? But I'll show you. W to C is 50. You can go back up and check. X to B is 30. Y to D is still 30. And Z to A is still 20. That's still 130 minutes. So it doesn't matter. Show them both if you need to. And you've got to give the cost as well. So this example here, we're going to do from scratch. Okay. Cost matrix is shown. Find the algorithm. You find the allocations by the Hungarian algorithm that will give the minimum cost. So in this first one, take away 80 from here. Take away 80 from here, take away 75 from here, and take away 85 from here. And when I do that, I'm going to get 30, 15, 60, and 0. 25, I'll just quickly fill this in to 65 and 0, 0 and 0 here, 65 here, 53, 5, 50 and 30. Okay, how many lines can I cover the 0? Just one. Okay, so that's not really going to help. So now, and I'll do it in red now actually, this column A doesn't have a 0. I'm going to take away 25. That's the smallest one. Column B, take away 2. Column C, take away 50. And that one stays as it is. So when I do that one, I end up getting 5, 0, 25 and 5. Take away 2 here gives me 13, 0, 1 and 3. And take away 50 here gives me 0, 15, 15, 10. And this one I left. Okay, cover my zeros. Again, I can do that one. I will definitely do this one because it covers 2 zeros, and it doesn't matter which way I do it, I get 3 there. Okay. Next step. Instead of doing 2 steps at 1, the smallest uncovered one is 1. So where I've got my dashes, my lines, all I'm going to do, if it's a double line, I'm just going to add 1. So the 0 stays at 0. It's only a single line. This 0 stays at 0. This 15, I'll do column C first. 10 stays as 10. It's only one line. The 15 has 2 lines. So I add 1, take away 1. It's just add 2, sorry, and take away 1. So really this just is like adding 1. So it becomes 16. This one stays as 15. This one stays as 0. This D stays at 0. This 0 over here, because it's 2 lines, adding 1 twice but taking away 1 is like adding 1, so it becomes a 1. That stays as 0, that stays as 0. All the other ones that are uncovered, I'm just going to take away 1 because that's what the whole thing was. Take away 1. So 5 becomes 4, 13 becomes 12, the 25 becomes 24, 1 becomes 0, the 3 becomes 2, and the 5 becomes 4. Okay, do your lines again. So I've got 2 lines there, 3, and it doesn't matter because I've got a 0 in the B and a 0 in C. Whatever I do, I'm going to get 4 lines. Definitely going to get 4 lines equals the 4 allocations. So now I'm going to draw my graph. So here I'm going to write W, X, Y, and Z. Here is my A, B, C, and D. Okay. Where the zeros are is where I can go. So W can go only to D. Directed. It's the only one where there's a 0. X can go to A and to B. X to A and to B. Directed. C can go to B and D. Sorry, not C, Y. B and D. Z, C, and, well, that's a 1 then. So that should be a 1C and C only. There we go. So now that I've done that, I can do my cost allocation. Okay, so cost allocation. So cost allocation W, 2, X, 2, Y, 2, and Z, 2. So Z can only go to C, Y can only, oh no, W can only go to D. They're the ones that only got 1 coming through, not a problem. X is B or A, and Y is B or D. Well, Y can't go to D because W has to go to D, so Y has to go to B. And therefore X has to go to A, we've got no choice. So now going back, W to D, 80. X to A and Y to B. X to A is 105, Y to D is 75. So 105 y to b. Y to b, 78. And Z to C, 135. 135 for my total. When I add that up, should be 398. Now it doesn't say minutes or anything, minimum cost. So 398 dollars as a cost. Example 2. Okay, it's easy to make a mistake here, so you've got to be careful. Right, again, straight away, we're going to take away from Dimitri 11, the smallest number, 13 here, 12 here, and 13 here. So when I do that, I will get 0, 0, 0, 0, and I get 51, 47, 51, 47, 49 and 50, 49 and 50, 133 and 133, 137 and 129, and 368, 346, not much space to write things in, 357 and 336. So there's all my zeros are just there. Okay, so that doesn't really help. So I'm going to do now from this column, the 400 meter column, smallest number that I will be taking away is 47. From this one here, the smallest number I'll be taking away is 129. And from this one here, the smallest number is 336. Okay, doing that one, these are my answers. 0, 0, 0, 0, 4, 0, 2, 4, 0, 2, and 3, 4, 4, 8, and 0, 4, 4, 8, and 0, 32 here, 10, 21, and 0. Putting my dashes, covering my zeros. So there, I will go along here. And I've got 2 zeros down in the bottom, so I'll go along there. 3 lines does not fit. Okay, so smallest uncovered number. Oh, that's smallest uncovered number is number 2. Number 2. Okay. To save us the work. Okay. All the uncovered, so no lines through it, we're going to take away 2. So we get 2 here, 2 here, 30 here, 0 here, 8 minus 2 is 6, and 21 minus 2 is 19. Okay, the others, if they've got one line going through it, they stay as they are. So this 0 stays as 0. This 0 has 2 lines at the J in 100 meters, so we're going to add 2. This 0 stays as it is. This 0 on the E has 2 lines, so you're adding 2 twice, but you're taking away 2, so it might as well stay as 2. Okay, the next one. That 0 stays as 0. That 4 stays as 4. This stays as 10. 3, 0, and 0. 2 lines down here. 2 zeros down here. And I'm going to go for 2 zeros across here. So I've got 3 only. Don't think I've made a mistake anywhere. No, don't think I made any mistake there. And we keep going. So now I've got to do the 2 is the smallest one. Okay, so I'll do this. This stays as 0, only one line. That stays as 2, that stays as 0. This one goes to 4. This one stays as 0. 2, 0, 0. This has got a double line, so I'm just going to add 2, so it makes it 5. This one, take away 2. no line. 4 take away 2 because there's no line is 2. 6 take away 2 gives me 4. This one stays as 0 because it's got 1 line. 30 take away 2 is 28. 10 take away 2 is 8. 19 take away 2 is 17. This has got a line, so 1 line, so it stays as 0. Okay, do it again. 2 zeros, 2 zeros, 2 zeros. Whatever happens, I've got 4 lines equals 4 allocations. So let's do our bipartite graph. Okay, so we've got D, J, C, and E. And that's going to go to the 100 meters, 400 meters, 800 meters, or 1500 meters. Okay, change my color. Okay, the zeros. D can only go to the 100 meters, or it can go to the 800 meters. J can only go to the 400 meters. That's the only one where there's a zero in there. C can go to the 100 meters or the 400 meters. And E can go to the 800 meters or the 1500 meters. So now we can do our cost allocation. Okay, D2, J2, C2, and E2. Okay, well there's only one going to 1500 meters, which is there, so we've got to keep that there. So that has gone, so then 800 meters has to be D, because that will be gone. Okay, so C can go to 100 and 400, and J can go only to the 400. So we better keep J at the 400, which means C has to go to the 100. And now we work out our cost from above, the original graph. D to 800, D to 800 is 144. J to 400, J to 400 is 60. C to 100, C to 100 is 12 and 349. So 12 and 349. 12, 349, I add all those up, I get 565, and I think it was in seconds. I'm going to write it up here, 565, and I think